Hello everyone, this is Stat 441 at Virginia Commonwealth University, and in this lecture we will discuss some ways to assess normality of a data set. Okay, so as we know that we discussed the normal distribution and how to calculate probabilities. Another thing that we will see in later chapters is that when we are trying to draw an inference, one of the assumptions is that the sample data comes from a normal distribution. So for that, there are multiple ways in which we can test to see whether the sample data that we have is approximately normal. Okay, so there are three methods that we will discuss here. The first method is the simplest one, and obviously we have discussed this earlier, is to make a graph using the data. So we can either construct a histogram or a stem and leaf plot for the data. And if the shape is approximately normal, if it's approximately mound shape and symmetric, then we would consider that data to be normally distributed. The second method that we can use is to find the ratio of the IQR, the interquartile range, and the standard deviation. And again, if it is approximately 1.3, then the data is approximately normal. The third method is to construct a normal probability plot, also called the QQ plot. And in this graph, and we will see in one of the examples, the graph, if the data is approximately normal, the points will fall on a straight line. So basically on the x-axis, we will plot the data, and on the y-axis, we will have the theoretical standard normal distribution. So if it's a 1:1 ratio, then we will have an approximate straight line on the graph. Okay. Here's an example to kind of show all these three. The EPA performs extensive tests on new car models and to determine their mileage. We have a data set which is 100 tests on certain new car models. Okay, and this is what the data set looks like. We have about 100 observations here, and we want to figure out if this sample is approximately normally distributed. Okay, so here is the histogram for this data. And as you can see, it's approximately normal. It's approximately mound shape. It doesn't need to be a perfectly normal distribution, but if we superimpose a normal graph on it, it is approximate. Then the next test would be to find the IQR is to S ratio. IQR is 2.7 for this data set. S is 2.4. If you need to review how to calculate IQR and the standard deviation, watch one of the previous lectures about numerical descriptors for data sets. Okay, now in this data set, the IQR S ratio is 1.12, which is approximately equal to 1.3. So again, the second test confirms that it is normally distributed. And the third, the normal probability plot, or the QQ plot. So in the normal probability plot, the observations in the data set are ordered on the x-axis, and on the y-axis, we can plot the expected value of the z-scores. So if the data is approximately normal, we would see a straight line, in a linear trend of the data versus the normal distribution. So here is the graph for the data set that we have. As you can see, all the data is lined up along this straight line, which suggests that it is approximately normal. Now we will be using this graph in one of the later topics, and at that point we will learn how to use R to get this graph. We will not try to do this by hand, but we will use a software to learn how to do this. Okay, here's another example. Here's just an example to kind of see where we can figure out the data is not normally distributed. So the researcher wants to analyze the data using a statistical method that is valid only if the data is normally distributed. And as you can see, this histogram obviously is not normal. It's heavily skewed to the right. So it would be incorrect to use a statistical method that applies to a normal distribution. So in the later chapters, when we are trying to create confidence intervals and conduct hypothesis tests, one of the assumptions for those inference techniques is that the data is normally distributed. And so you should always make sure using one of these techniques to figure out that the data is normally distributed. If it's not normal, then those techniques should not be applied. All right, so that's all for this topic. Thanks for watching.